Okay, so what we need to do, I did name acid anhydrides. Did I name them?
Yeah.
Okay, so what we will do, we'll look at now straight away reactions of acid anhydrides. Now remember what I said in my last lecture, and that was that acid anhydrides are less reactive than acyl chlorides. So the one that I always choose is this one here, which is ethanoic anhydride. And the reason for the choice is simply because the AQA exam board tends to ask this a lot. So does the OCR, but the AQA. So what I'll do as normal, I'll put here its name, ethanoic anhydride. And we've got the full board here so we can utilize this. So we need to know all four reactions that I did with acyl chlorides, like with water, with alcohol, with excess ammonia, and with an alkyl amine. So what I'll do is use the green here and put water here, water liquid. And what that does, it hydrolyzes from here the acid anhydride link, and we end up with two molecules of ethanoic acid. Okay. We don't need to put a 2 there because remember this is only a reaction scheme. I'm not trying to balance an equation. So this here is ethanoic acid. Okay. Then we have the reaction within alcohol. Now this is the one where we have to be careful, and the other ones, because is it 1-to-1 or is it in excess? So if I just say you've got ethanol added, yes, then you have to automatically assume it is not excess. Okay? That's the way the AQA exam board works. If it says excess, it will say so. Okay? So just repeat that. Even in this exam, if they say ethanol, do not make the assumption it's excess. Please don't do that mistake. Okay? Because if they say excess, they will say so. So this one here is 1-to-1. And when you have 1-to-1, I think I'll need this part of the board as well, actually. Then what will happen is I'm going to put square boxes. You get one molecule of the ester, which is ethyl ethanoate. As you know, it has a sweet smell. Plus, you get one molecule of ethanoic acid. Okay? What I'll do, I'll put this in a beautiful square box for you so they stand out. Sure, I'll just use the board, I think, here. There we go. So this is one molecule of each. Now, if we use excess ethanol, then all you're going to get is 2 molecules of the ester. That's it. You don't get any of that. We're going to look at the equations as well on that side. So all we're going to get when we use excess ethanol, you're just going to form 2 moles. But remember, when I do the equation balancing, I'll put that here. But in this scenario, we'll just put it like that. You will, it looks hard, but trust me, it isn't hard because there's a pattern. And you will notice a pattern coming in a minute. And patterns help us to learn a lot. Makes the life a lot easy. So here we go. Now I'm going to deal with ammonia. And the same thing with ammonia. We've got ammonia liquid and then excess ammonia. There we go. So you'll see when we use just, it says ammonia, that's 1-to-1. So that means 1 mole of the ethanoic anhydride reacting with 1 mole of the ammonia. And in which case we'll get 1 mole of the amide plus 1 mole of the ethanoic acid. You'll see a pattern. I told you you'll see a pattern. Patterns is the key to this. Right, we'll just put a border around this. Like so. Stands out. Right, and then tissue paper. Actually, just give me a second. I think. Oh, there we go. The paper just knocked this bit out. Okay, then when we use excess ammonia, you will form only 2 moles of the amide. You will not form any of the ethanoic acid. And finally, we have alkylamines. So here, with the one we chose, and I'm using the same one that I used the example, you know, when I did the acyl chloride, I used the same example. So here we're using methylamine, and then here we have excess methylamine. Right, so when we use 1:1, similar pattern, you'll get 1 mole of the N-substituted amide. We covered that in our last lesson. This one is N-methyl. Do you remember when I named it on that side of the board? So the methyl is directly connected to the nitrogen atom, so that's why it's called N-methyl ethanamide. Plus, now I don't have much space, but what I'll do is just slip it in down here. Is that okay? Just here? Yeah. And then you form 1 mole of the ethanoic acid. Can you see the pattern is the same though? And finally, when we use, excess methylamine, the only thing you will now get is 2 moles of the N-substituted amide, and you won't get anything else. So you get 2 moles of N-methyl ethanamide. Okay, so that's the first thing. Now the good news for you is that on the AQ exam board, we don't need to know the mechanism, but we are expected to be able to write the equations. Okay, so what I'll do now, I'm going to the other right-hand side of the board, this side, and I will write the 1 by 1, and you know how I will do everything. I start from the top and work my way clockwise. So we'll start off with the water one first. So I'll just put here reaction of ethanoic anhydride with water. Now, if we look at the, so you are allowed to put it as a displayed. In fact, I would encourage you to do so, but there are other ways. Okay, so there it is. You're reacting with water and you get 2 moles of ethanoic acid, like so. Now let's double check, is this balanced? Well, we've got 1, 2, 3, 4 carbons on the left, 2 times 2 is 4, hydrogens 6, here 6, 7, 8, 1, 2, 3, 4, 4 times 2 is 8, and oxygens 1, 2, 3, 4, 1, 2, 2. You happy? There's nothing else formed, so it is perfectly balanced. Now the only warning I will give you on this is this, and I've seen this so many times on the AQA, and it works. They do manage to trick you. You know, when they do that, you get confused in an exam. You look at that and you go, what on earth is that? CH3, CO, bracket 2. What that is that part and that part. Do you see? And that oxygen is here. Look, you see that? So this is a warning to you. Be very, very careful, because on the OCR exam papers it's the same. AQA doesn't often do it, but I have seen it. And the problem is you can't do a question if you don't know what that means. So we are now, you will recognize that. Oh, hang on a minute, that's an acid anhydride. Yes? So just be very, very careful of that. Right, now we move on to the reaction with the alcohol. So reaction of ethanoic anhydride with ethanol. And the way I do that is very, very simple. So we have 1:1 And there, that is, we have, there we go. Okay. Plus one molecule of ethanol, and you'll see, and that will form, look what I've put, exactly what I put, it will form one molecule of the sweet smelling ester ethyl ethanoate, plus one molecule of ethanoic acid. Now we've got to check this is balanced. So we've got 1, 2, 3, 4 carbons here, 4, 5, 6. 1, 2, 3, 4, 5, 6. Perfect. Hydrogens, 1, 2, 3, 4, 5, 6 there. 6 and 6 makes 12. Okay. So here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And finally oxygen 1, 2, 3, 4. 1, 2, 3, 4. Perfect. It's balanced. The next one is in excess. So what we mean by that is you've got 1 mole of the acid anhydride versus 2 moles of the alcohol. Happy with that? So here I go again. Remember, you are entitled to do it like that as well, by the way. That's your choice. I've just gone for display formula because, as I said, most of my students do agree, when it's displayed, you can see it a lot better. The functional groups are exposed and all the chemistry is a lot better to see. So here you will notice if you've got a highlighter with you, what you can do is, can you highlight that too? If you've got one there, haven't you? So highlight that too for me, and that just stands out in the notes that it's excess. So when it's excess, we're going to get 2 obviously moles of the ester. Okay, now I'm pretty sure there's also a molecule of water that is formed, but let's double check. So carbons 1, 2, 3, 4, and 4 and 2, 4 there, 8. 1, 2, 3, 4, yeah, that's okay. Hydrogens 1, 2, 3, 6, and then that's 12. Agree? What's 12 and 6? 18. So let's have a look here. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So 8 times 2. 16, yes? So there's 2 missing because it was 18. Do you get it? And I could prove further. Oxygen 1, 2, 3, and here it's twice lots of ethanol, so that's 2, 5. 2 plus 3 is 5. And here 2 times 2 is 4. Yes, I was right. So without the water, this will not balance. Okay? You have to put water. Here we didn't need, but here we do. And this pattern now you'll see. Now we move on to the ammonia, and I've got a little bit of space, so what I'll do, reaction of ethanoic anhydride with ammonia. And once again, it will be 1-to-1 and excess, so 1-to-1 with the green. So I've just about got a space here. So there's my acid anhydride. Plus ammonia. And remember, it's 1-to-1 like that. So what you will form is 1 mole of the ethanamide. If you say it slowly, it's an ethanamide, quickly ethanamide, plus you will form 1 mole of ethanoic acid. And if we very, very quickly just double check, this is all balanced. So you've got 4 carbons here, 1, 2, 3, 4. Hydrogen 6 plus 3 is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I don't need to check anything else. Make sense? And I think I just might have enough space. 1 to 2, just about. So this is the excess. Right. So this is with excess. So here, once again, get your highlighter and shade in the 2. I would shade in the whole ammonia so you know it's in excess. So big 2, we're going to get 2 moles of the ethanamide, plus you're going to get water. Do you see the pattern? Yeah. Okay, I'll let you copy that. And then I got no space, so what I'll need to do is rub the top one off, make space, and I'll do this last one, the N substituted. Okay, so the key message here is you do not need to know the mechanism of any of these. It's only for the acyl chlorides. All we are expected to know is the reaction and an awareness of the reactions of this nucleophilic addition dash elimination, yes, of acid anhydrides. So what happens when you use 1-to-1 of these nucleophiles, as you've seen in green, and what happens when you use excess? Can I just rub the top bit off? Yeah. Okay, so what I'll do, this is the reaction. Just rub this bit off. Make space. Right, so this one is the reaction of ethanoic acid with methylamine. So what we have here, so this is 1-to-1. Just put that in green. And you will form 1 mole of the N-substituted amide, which is N-methyl ethanamide plus 1 molecule of ethanoic acid. And when you do excess, or 1-to-2, we end up with just 2 molecules of the N-substituted amide. So once again, get your highlighter, highlight that, so it's excess, and we get 2 molecules of the N-substituted amide when it reacts with the alkylamine. There we go. Plus you will get, oh, I'll rub it out, water. And that beautifully balances as well. Yeah.